We're going to be dealing on the applications of what we already know as special angles. When we worked on sine 30 in trigonometry part 1, we worked on cos 30, and we also worked on tan 30. We worked on sine 60, cos 60, and tan 60. Then we also worked on sine 45, cos 45, and tan 45. So like I said, now we are going to be dealing on the applications, and we have some great questions here. One of them is we have a triangle in these aspects. We are given a triangle, like this, and we are told that this angle is 45 degrees. Then we have B, A, and we are given C, and we are given that B is 7, B is 2 centimeter. Now we are giving B to be 2 centimeter. Now that we are told to find the value of A and C. Now in this question, what we are going to do is to understand the question critically. Like I said at the beginning, this place that is opposite to this angle is known as, this is special angle. The line opposite to this special angle is known as the opposite. So here is known as the opposite. The line not directly opposite to the special angle, the specific angle is known as the adjacent. I believe you can see that there's no line, there's no angle facing here. So this is known as the adjacent. Then the line facing the right angle is known as the hypotenuse, like we said in our last class. So we have the opposite, we have the adjacent, and we have the hypotenuse. Now, apart from that, we also have other things which we need to know. The line facing the specific angle is known as the opposite. The line not facing the specific angle is known as the adjacent. And the line facing the right angle is known as the hypotenuse. So that's the first thing you need to know. Then the second thing is we have other things which we are going to do, which we already talked on in our last class. Now we have, if here is the opposite, and here is the hypotenuse. What does it represent? We have SOHCAHTOA, which I talked about. SOHCAHTOA, where we said S, which is sine, represents opposite over hypotenuse. So if we are working with sine 45, because our degree is 45 degrees, it's going to give us opposite over hypotenuse. Now we'll ask ourselves, what's the opposite here? The opposite is given, the opposite is A, but what's the hypotenuse here? 2. The hypotenuse is 2. So from here we can work on it, and sine 45 is sine 45 over 1. So we have that, we're going to cross multiply to give us 2 sine 45 degrees is equal to A. Now we have that 2 times. Now you go to the last video, or you go to your notes and check what sine 45 is. We said that sine 45 is root 2 over 2. So if sine 45 is root 2 over 2, we have that 2 times root 2 over 2. We have that 2 here, we have that 2 here 1, 2 here 1. So our answer will give us root 2. Means that A is root 2. A is root 2. Now if you go and check what's the square root of 2, you ask yourself what's the square root of 2, and from there you'll be able to get your answer. So A is root 2, and our answer will be 1.4142 centimeter. That's the first part. Then also, if we are going to work on C, C is our adjacent. So if we are working on adjacent over hypotenuse, we know that we are going to be working with cos 45 degrees. And what's our adjacent? Our adjacent is C. Our hypotenuse is 2. So we have that cos 45 degrees is equal to C over 2. So we know that cos 45 is cos 45 over 1. So we have that 2 cos 45 degrees is equal to 2. So from there, we are going to also get the same answer, which is 2 times what's cos 45. Remember that cos 45 and sine 45 are the same. So we have that equal to C. So we have that C is equal to root 2. And if you use your calculator to check what root 2 is, root 2 is 1.4142 centimeter. So take note of this point. We can have from the triangle, you make sure you check what is available, because anytime you are doing a triangle like this, you definitely be told what's available. So from here we can see that 2 is available. That 2 represents the hypotenuse, and if the hypotenuse is available, therefore we can find the opposite and we can find the adjacent. But in a situation where the hypotenuse is not available but we have the adjacent, definitely we can find the opposite and we can find the hypotenuse. What about a situation where we don't have the adjacent and the hypotenuse, but we have the opposite? We can therefore use the opposite to find the hypotenuse and the adjacent. So take note of this valid point in this first session. So apart from this, we also have some rules which we've not talked about. So I'm going to drop some rules and some formulas for each and every one of you watching this video. So make sure you follow up these rules which I'm going to talk about. Now we have 2 rules. The first one is known as the sine rule. We have the sine rule, and we have the cosine rule. We have the sine rule and we have the cosine rule. So in sine rule and cosine rule, let's assume we have a triangle like this. Now we have a triangle, assuming that all the sides are not equal. So we say here is A, here is B, and here is C. Now the line facing big B is known as small b. The line facing big B is known as small b. The line facing big A is known as small a. The line facing big C is known as small c. But now we don't even know the values. We want to know the value of these sides and these angles. So maybe you are given CB and you are told to find B. We are giving A, B, C. We are giving us A, B, C, or something like that to find one of the angles. How will you go about it? This is where sine and cosine rule comes into play. So we have that A. We have that A. A is usually the small letter. A over sine A is equal to B over sine B is equal to C over sine C. So this is for the sine rule. The sine rule, we have that A over sine A is equal to B over sine B is equal to C over sine C. Take note of this valid point. Why for the cosine rule? The cosine rule is different. The cosine rule, you have the following. You have that A squared equal to B squared plus C squared minus 2BC cos A. You have another one which is B squared equal to A squared plus C squared minus 2AC cos B. Then you have that C squared equal to A squared plus B squared minus 2AB cos C. So we have equation 1, equation 2, and equation 3. So we have the first one. We have the A squared equal to B squared plus C squared minus 2BC cos A. Then we have the next one, which is B squared equal to A squared plus C squared minus 2AC cos B. We have the next one, which is C squared equal to A squared plus B squared minus 2AB cos C. So these rules are very much important. Then another thing you need to take note of, which is not under the sine and cosine rule, but I will just let you know that we have that sine squared theta plus cos squared theta is equal to 1. Take note of this point. Sine squared theta plus cos squared theta is equal to 1. And the second thing you need to know is that cosec theta is equal to 1 over sine theta. We have sec theta is equal to 1 over cos theta. Then we have that cot theta is equal to 1 over tan theta. Take note that sine squared theta plus cos squared theta equal to 1. Cosec theta is equal to 1 over sine theta. Sec theta is equal to 1 over cos theta. Cot theta is equal to 1 over tan theta. Now this cosec you are seeing here, this cosec represents cosecant. This sec you are seeing here represents secant. Sec represents secant. Cot represents cotangent. Cot represents cotangent. Then tan represents tangent. So tan represents tangent. Cot represents cotangent. Sec represents cosec. Sec represents secant. Cosec represents cosecant. Now let's go again. Sine rule represents that a small a over b over sine big A equal to b small b over sine b, c over what? Sine c. While for the cosine rule we have that a squared plus b, a squared equal to b squared plus c squared minus 2bc cos a. We have that b squared equal to a squared plus c squared minus 2ac cos b. The next rule we have that c squared equal to a squared plus b squared minus 2ab cos c. So take note of these rules while we move on to the next question. So move on to the next question right away. And don't forget to share these videos with your friends in case you have friends in SS1 or friends that are definitely going to write WAEC, because everyone needs mathematics. So it's very important that you share this video with your friends. So we move on to the next question. So the next question we have that without using logarithm table or without using tables, you have that cos square 45 degrees minus 1 e over 1 minus cos 45 degrees. You are told to solve this equation or solve this particular expression without using table. Now it's very simple. The first thing you need to know, like I taught my students in class, understand that there is a topic, there's a part of what quadratic equation which has to deal with something called difference of two squares. Now under difference of two squares, you will have two squares. For example, x squared. For example, you have x squared minus 9. For example, you have x squared minus 9. Let's assume you have x squared minus 9 now. X squared minus 9, this 9 can be broken down to a number that is raised to the power of 2, which is x squared minus 3 squared. So if we have x squared minus 3 squared, we can break this down to x minus 3 into x plus 3. As you can see now, this 9 here was broken down to 3 squared. And this 3 squared, you know that whenever we have something they call difference of two squares, under difference of two squares, we have that you have a negative sign and a positive sign. So there will be x minus 3 and x plus 3. So if you are told to analyze x squared minus 25 using difference of two squares to give us x squared minus 5 squared, which is x minus 5 into x plus 5. What about x squared minus 16? We have to give us x squared minus 4 squared, which is x minus 4 into x plus 4. What about x squared minus 64? X squared minus 64 will give us x squared minus 8 squared, which is x minus 8 into x plus 8. So what if we have x squared minus 1? X squared minus 1 can go down into x squared minus 1 squared, because you know 1 times 1 is 1. So we have that to give us x minus 1 into x plus 1. So if you have broken this down, to this level, x squared minus 1 is x squared minus 1 squared, and you have that it gives you x minus 1 into x plus 1. Then also we can break cos squared 45 degrees. Cos squared 45 degrees. Now take note that this cos squared 45 degrees is equal to cos 45 degrees squared. Take note that cos squared 45 degrees is equal to cos 45 degrees squared. So if cos 45 degrees is squared, it is cos squared 45 degrees. What about sine squared 45 degrees? Sine squared 45 degrees is sine 45 degrees squared. What about tan squared 45 degrees? Tan squared 45 degrees is tan 45 degrees squared. So if you understand this point, everything is now very simple. Take a snapshot here. Now you see this x squared minus 1 and this cos squared 45 degrees minus 1. They are similar. So since they are similar, you have to reduce this to this. Now, we are going to try it out right away. We are going to reduce it the way we use difference of two squares to analyze the question. So we are going to try it out and see what we can get out of it now. So in this part, we'll break it down. We have that we have cos squared 45 degrees minus 1. So this will definitely give us cos 45 degrees plus 1. Or let's start with minus, because we're starting with minus. Then cos 45 degrees plus 1 over 1 minus cos 45 degrees. Now you check very well, are they similar? These two, they are similar, but can they cancel out? No. So what you are going to do now, remove this minus 1 here. You see that this place is 1, so remove this minus 1 here by bringing out minus 1. Then you bring out minus 1 from cos 45 to give us minus cos 45 degrees. Remove minus 1 from minus 1, what will it give you? Plus 1. What do you have here? Cos 45 degrees plus 1 over 1 minus cos 45 degrees. So what do you do next? You bring this one forward, because see we have 1 here, so 1 has to come forward and take this one to the other side. So you have minus 1 into 1 minus cos 45 degrees into cos 45 degrees plus 1 over 1 minus cos 45 degrees. So they look similar, you cancel out cos 45, cos 45, and now we have our answer to be minus 1 into cos 45 degrees plus 1. Now we've gotten to this level, but we are not done yet. What you need to remember is, what's cos 45 degrees? And we are all aware that cos 45 degrees is equal to root 2 over what? 2. Cos 45 degrees is equal to root 2 over 2. So from there we now come here to simplify and write into root 2 over 2 plus 1. And this will give us, open the bracket, minus root 2 over 2 minus 1. And that will be our final answer. So our final answer is minus root 2 over 2 minus 1. Minus root 2 over 2 minus 1. So that is it.